few basics of electric panels, electric boxes. Do distinguish and determine between the main box and the sub panels, because you could have a sub panel. One way to tell, you'll have main power coming in the top, and then you'll have another source of power leaving, going to a sub panel. So in this case, this would be the main box, and then I'd have power leaving going to a sub panel. But when you open up a box, the first thing I'm going to look at is, and it's difficult to see, what size service do I have? In residential settings, typically you'll have a 100 amp service or a 200 amp service. I don't know if you can see here, but in this case we have a 200 amp service, and this is considered my main breaker. What that simply means is I have power coming from the main, the transformer, tying into this lug and this lug, because I have two mains coming in, and then I have two neutrals and a ground wire designated by the green, the neutral designated by the white strip, the hot designated by the red strip. They don't all have this. This is nice. And then my neutral is pure black. But keep in mind, on the main power coming in, both our legs coming in are hot. One way you can verify that is use any multimeter. I prefer the Fieldpiece LT17A because it has detachable leads and about everything you'll need. And we're going to turn it to the V with the squiggly line indicating AC power. Turn on my light. The V with the solid dash line is DC power. All service is AC power. So we're going to turn it on to 600 AC, and I'm going to test from one leg to neutral. I have 117. From the other leg, I'm sorry, not to neutral, to ground, I have 116. Now from each hot leg, I have 204. It's not going to be exact. That would be called a 208 volt service. That is well within within reason to be considered 208. So this box would be considered a 200 amp service with 208 supply voltage going out to my equipment. I don't have any breakers in this box. We'll do that in a later video because I want to illustrate something. When you're testing legs, if you test to neutral, it'll show you the voltage on one leg. So neutral to each leg, I'm getting approximately 116. If you test the ground, it'll do the same, but 117. But if you test to each leg, it gives you the total voltage you have available. And if you look closely, this leg coming in powers this bus bar. This leg coming in powers this bus bar. We can do the same thing, check into ground. We can check to see if we have power on the bus bar. We do not have power on that bus bar. We do not have power on this bus bar. These bus bars alternate between your breakers. So if I were to stick a breaker, a single pole breaker here, I'll have 115 volts coming out of it. Single pole breaker here, 115 volts coming out that way. If I put a double pole, it'll grab both of these tabs and I'll have 240 coming out of the breaker. So you have to grab both buses to get 240, one bus to get 115 or 120. That's how you power different types of equipment that require different supply voltages. For example, a gas furnace is only going to require one bus bar. An outdoor condenser unit is going to require 1, 2, both bus bars. The difference, the gas furnace gets 115. The condenser unit will require 240. You can determine the supply voltage required by looking at the tag. Now, I know I don't have voltage on this bus bar. I just tested it to ground, but always verify. So confident, don't do this ever. I can touch the buses. However, as soon as I turn on my main, oh boy, this is a tough breaker. Now this is energized. Our hot leg is energizing this bus bar. This hot leg is energizing this bus bar. How can we verify that? 117 to ground. 116, both. 204, 208. Now, it is so very important to understand the anatomy of a bus or a breaker panel, to understand what will shock you when your main is turned on, what will shock you when your main is turned off. So let's review that very quickly. Right now, my main's turned on. It will always shock me coming from the main box. But now each bus will shock me as well. These tabs will shock me. These lugs feeding a supply panel will shock me. Okay? As soon as I flip it off, and never trust it, always verify, make sure your breaker didn't fail. Now I cannot be shocked by the bus bars. Okay? It's important to understand that. Also, it's important to understand that you have two, or in this case 3, most have two other bars or 3 bars. This is your ground bar. All your grounds need to be connected to your main ground, which will then be driven into the ground, typically 8 to 12 feet. And then you have a neutral bar. If you look up here, this bar is tied to your neutrals coming in. One neutral is going to our sub panel, one neutral is coming to our main. But you do not want to tie, a common mistake people make, they'll tie their neutrals to their ground bar or their grounds to their neutral bar. There are reasons we'll talk about later why you want to keep your ground separated to one bar, your neutrals separated to another bar. Just keep that in mind.